Right, welcome back from the break. Today we have with us Stephen Bradshaw, who is going to be showing with us Active Directory enumeration with LDAP. Welcome, Stephen. Thank you.
Thank you. Thanks everyone for coming. Can you hear me all right? Yep. Today I'm going to be talking about Active Directory enumeration using LDAP. So, who am I? My name is Stephen Bradshaw. I'm currently a Principal Security Consultant in the Offensive Security team at SEEK. I do a bunch of different internally focused offensive security work. So I do pen testing, vulnerability hunting, red teaming, purple teaming, and I build and maintain systems for use in offensive security work. So this is an overview of what I'm going to be talking about today. I'll talk about how Active Directory and LDAP are interrelated. I'll talk about the types of information you can get from LDAP, from Active Directory, and the security relevance. I'll talk about the technical details of this data collection, and I'll talk about some of the enumeration tools that can be used for this purpose, for the purpose of getting attack information, how the tools work, and what their limitations are. So, what is LDAP? How does it relate to Active Directory, and why should you care? LDAP stands for Lightweight Directory Access Protocol, and it is essentially a vendor-neutral standard that allows you to query information about network objects from a directory service such as Active Directory. Active Directory actually uses LDAP as a mechanism by which clients can query information about network objects, and as such, each domain controller by default includes an LDAP server listening. The relevance for attackers is that under the default settings, any authenticated user can quickly gather a large amount of information that is useful for identifying or facilitating attacks in one place. So the information you can collect includes information such as permission relationships between objects, so what objects can act in which ways on what other objects. You can get lists of domain users and their details. You can get lists of domain groups and their memberships. You can get lists of the computers that are a member of a domain. You can get information about which object group policy objects apply to. You can get information about trust relationships with other domains and the nature of that trust relationship. And you can get information about the configuration of Active Directory certificate services. So this information can be used to identify the opportunity to perform a number of different types of attacks that are useful for lateral movement and privilege escalation. So some of these attacks include Kerber roasting and ASREP roasting, gold and silver ticket creation, Active Directory ACL abuse, so that's basically identifying opportunities for abuse based on Active Directory ACLs, DC sync, domain and forest trust abuse, constrained and unconstrained delegation, certificate services attacks, and you can use LDAP to actually directly recover certain alternate password types if you have the right permissions. This includes passwords such as LAPs. So the process of actually collecting a lot of this information, particularly if you're specifically considering it for the purpose of attacking Active Directory, can be quite complex in certain ways, and it's best to use custom tools for the purpose. However, while these tools are really great and they do a lot of work for us, there are cases in which they can fail in unfortunate ways, and due to the value of the information we can get, it's really good to understand how the collection works so we can troubleshoot any issues, and so we can pursue alternate collection strategies where they might be appropriate and where they're available. So that being said, let's dive into the details of how this collection actually works. So I've outlined here a 4-step process for actually performing this collection. The first step involves discovering the domain controllers that you actually want to enumerate. Second step is connecting and authenticating to a particular domain controller. The third step is querying and parsing the data, so it's in a useful format that you can use. Then, finally, you want to be able to interpret and present it in a format that's useful so you can actually identify useful attack opportunities. So in the following slides, I'm going to talk about each of these steps in detail. We'll start off with talking about how to actually discover domain controllers on an unfamiliar network. So a concept that's useful to be aware of in this case when we're talking about identifying a domain controller that we want to enumerate from is the concept of the global catalogue. So this is essentially a server role that's associated with domain controllers in an Active Directory domain. Servers that have this role basically can return information on any object within the forest. So if you're looking for a particular server to enumerate from, these are the best types of servers to preference the global catalogue servers. The first discovery method I'm going to be talking about is port scanning. So each domain controller basically exposes a very unique set of ports to the network that's required to basically perform its regular operations. And the combination of these ports makes it really likely that any server that exposes all these ports is a domain controller. So those ports include ones such as TCP UDP 53, which is DNS, TCP 88 Kerberos, TCP 389, which is the plain text LDAP port, TCP 445, which is the CIFS file sharing port, TCP 636, which is the secure LDAP variant, secure as in TLS protected. And you'll often also see a number of different remote management services such as RDP, which is TCP 3389, Windows Remote Management, TCP 5985, and the secure version of the same, TCP 5986. So if you identify a single domain controller via this approach, the port scanning approach, there is a way by which you can determine it is a global catalogue server. It's not the easiest approach, and I'm going to be talking about an easier approach to do this later on, but what you can do to determine if a particular domain controller is a global catalogue server is you can perform an anonymous bind with LDAP using tools that allow you to do this and check for a particular property, and that is the info other is global catalogue ready property. So if this is present in the LDAP server settings under domain controller, that server is a global catalogue server. So this general method of port scanning is a good way to start a discovery process on an unfamiliar network, because basically all you need is just some network range information that you can actually hit with a scan. Now let's look at the second discovery method. So this is DNS. So if you know the DNS domain name associated with an Active Directory domain, and you can perform DNS resolutions against that domain's DNS database, then you can actually identify domain controllers and global catalogue servers using two different DNS enumeration approaches. So if we take an example DNS name of example.com, if we do an A lookup of example.com, that'll give us a list of all the IP addresses of the domain controllers within that domain. Secondly, if we look up a record with the name of gc._msdcs.example.com, that will list the IP addresses of the global catalogue servers within that domain. So this approach is good for identifying all of the domain controllers quickly. However, you need some information, you need a domain name, and you need some access. You need to be able to do DNS queries. Now, the question you might have at this point is, if you don't know the domain name, how can you actually go about identifying it? If you've gotten access to a network via compromising a Windows machine that's a member of the domain, then you can obviously get that locally from that particular machine. But if you haven't gotten access in that way, there's a couple of different approaches you can use. So it basically starts by finding at least one Windows machine within that domain via a port scan or other method, and then using one of these three methods to actually pull back information about the server name of that machine, from which you can infer the domain name of the DNS of the Active Directory domain. So this can be looking at certificates presented by TLS services. So some examples on the slide there are LDAP-S, RDP, HTTPS, and Windows Remote Management. So basically, if you connect with something like the OpenSSL S client, you can actually get back the certificate and look at the details of it. You can also do one of those LDAP anonymous binds that I mentioned earlier, and that server information will have information about the domain name of that particular system. The best approach, the one I like the best, is using this tool NTLM Challenger, which is actually linked on the slide. So what you can do with this tool supports a number of different approaches of enumeration, my favourite of which is the CIFS enumeration technique. If you find an open CIFS port, like a file sharing port, port 445, open on a Windows box, it's a member of a domain, you hit it with this tool remotely without authentication, it will actually give you a bunch of information about the domain membership of that machine, and that will tell you the DNS domain name associated with its domain controller. Now, the best approach to actually do this type of enumeration is to combine the techniques together. So my suggested discovery approach is as follows. First, you get the DNS domain name of the associated domain, port scanning, use one of those techniques I mentioned earlier. Then find a DNS server that you can use to do queries against. So ideally, you'll find a domain controller by port scanning and use that because that has an exposed DNS server that you can use directly. But sometimes you can find cases where other DNS servers will recursively resolve to that server and you can use that instead. So find a DNS server by scanning for port 53. Then use the DNS enumeration technique to enumerate the IP addresses of the global catalog servers and the domain controllers using the DNS technique I mentioned earlier. Finally, port scan all those IP addresses with a preference for the global catalog servers to confirm that you can actually talk to them. So just because you can see them in DNS enumeration, you can get the IP addresses, does not mean you'll be able to talk to them from wherever you are on the network. And the specific ports you want to be able to talk to are generally 389 or 636 for LDAP. So we've talked about how to discover domain controllers. Now let's talk about how to connect to them. So we want to connect to one particular domain controller, pick one that you can talk to, and that is hopefully a global catalog server. Then, for the purposes of the enumeration that we're talking about, the basic communication only requires that you be able to talk to one of those two ports. LDAP, which is TCP 389, or secure LDAP, which is TCP 636. You've got a number of different authentication options that you can actually use. So you can use anonymous authentication, an anonymous bind. You can use NTLM, either a plain text password or you can use pass the hash, if you're familiar with that technique. You can use simple authentication, which is a username and an unencrypted password that's unique to LDAP, that particular specific approach, and Kerberos. So there are some additional caveats for Kerberos. You need to perform the bind using the DNS name of the server and not its IP address. And you will need to be able to talk to TCP port 88 on a domain controller if you don't have the appropriate service ticket already cached. Now, in terms of the access provided by these different authentication methods, the anonymous bind will generally only give you information about the LDAP service itself. It will not give you any information about any directory objects. There can be cases where the Active Directory domain is misconfigured and you will get more information back, but this is kind of rare. By default, you'll need some form of valid credentials to actually get back most of the data that we're going to be talking about in this presentation. So now, at this point, it might seem like I'm really kind of belabouring simple details, but this amount of detail, or these particulars, really become relevant if we're connecting to the domain controller under some form of restricted circumstances. So if we need to talk to it via port forwarding, if we need to tunnel through a C2 implant, or if there are restrictive traffic rules in place in a firewall or something similar to that. There's a couple of other caveats that apply to LDAP-S as well. So this is basically listening on TCP port 636, and it requires a TLS negotiation to be created before you can communicate on this port. Now you can have cases where port 636 will appear to be listening on a domain controller, so a port scan will show it open, but there is no certificate configured associated with the LDAP service. And in these cases, you're not going to be able to talk to it via LDAP-S. You generally see this on new or under-configured domain controllers. Hopefully you won't see it too often, but I've seen it a few times. In addition, there can be restrictions on certain authentication methods in such that they will only work using secure LDAP. So you'll be able to tell if this is the case if you try and log on with what you believe are valid credentials to the plaintext LDAP and you get an access denied. So if you see this, it's worth trying again with secure LDAP to see if that is the problem. So we've talked about discovering domain controllers and connecting to them. Now let's have a look at querying. So this here shows a diagram of what an LDAP hierarchy looks like. So it's a hierarchical structure set up like a tree, and when you perform queries, you can perform the query at any level of the tree, and the query can be recursive or not. LDAP also has its own very unique query language that we're going to have a look at in a moment. It takes a bit of getting used to. And it works by filtering objects to return based on attribute values. So this here is a very simple example of an LDAP query. So each LDAP query is comprised of one or more query conditions, which are grouped together with sets of brackets. And in this case, what we're looking for the object class attribute of the object to be equal to the value of group. So as you might expect, this is looking for group objects. So the queries can also get a lot more complex. So you can have multiple query conditions. You can have value wildcards, which is an asterisk. You can group queries in various different ways, logical ands and ors. Those are ampersands and pipes, respectively. And you can negate query conditions with an exclamation point. So when we consider the ands, ors and negations, these actually go within their own query condition, so they need to be surrounded by their own set of brackets, which basically group together the conditions that the negation or the grouping applies to. So this here is an example of a query that is anding two different query conditions. So we're going to have a look at it in a bit more detail on this slide here. So essentially, we open bracket, ampersand for and, we have our first query condition. Immediately following it, we have our second query condition. It's one of the unusual things about this syntax. And then we close it at the end with a set of brackets. So to break it down, we've got an and then that condition, and then that condition. So the and can have two or more conditions in it, and they just basically go directly after each other like this. So no commas, no separators, they're just directly after each other. It's one of the unusual things about this. We also have a concept of special comparators. So a lot of the other examples we've looked at so far have used a simple equal as a comparator in the query condition. We can use these operators to do more complex types of comparisons. So we have 4 different types that are supported within the Active Directory LDAP standard. These include a bitwise and, a bitwise or, a transitive eval, and DN with data. The last two are very rarely used. I don't think I've ever seen examples of it in live. Transitive eval is basically querying across links, and that's out of scope for this talk. DN with data is basically matching on a portion of a binary value. So this particular example that we have here shows an example of bitwise anding. So let's explore it to see how it works. So this query is basically looking for Kerberoastable users. So these are basically user accounts for which you can capture a Kerberos ticket, and you can subject that ticket to password cracking, and then you can get that user's password back. It's a mouthful, isn't it? So this query is anding a bunch of different conditions. We're anding object class equals user. Service principal name equals asterisk. This just means a service principal name of some value must be set. Then we're negating a condition. CN equals KRB TGT. CN stands for a common name of an object. And here we're basically looking to exclude the object with a common name, KRB TGT, which is the Kerberos ticket granting ticket account. Essentially, it's got a long randomly chosen password, so we're not even going to bother trying to crack it. Then we have a final condition, which is also negated with the exclamation point, and we're looking at the user account control attribute, and we're using a bitwise and we're looking for the value 2. So what is this doing exactly? So user account control actually stores an integer that represents a number of different properties that relate to user account security. So basically, if you want to find out if any of the individual properties stored by this is present, what you need to do is you need to know its associated integer value. In this case, we're looking for 2, and you need to perform a bitwise operation to extract and see if that property is set or not. So in this case, 2 relates to disabled users. So what we're doing here, we want users with a service principal name that are not named that and are not disabled. So this example comes from that link down the bottom there, and that has a bunch of other similar examples of queries that are attack specific. And there's two more here from SpectreOps. So we've talked about finding domain controllers, connecting to them, and how to actually query data. Now let's look at how we actually interpret what we get back. So this here is a screenshot of a number of different attributes associated with a user object in my test Active Directory tree. So if you look at some of the values, you will note there's a wide variety of types. We've got integers, we've got dates, we've got strings, we've got Boolean values, we've got binary data, and then we have values like our user account control, which is comprised of a number of other properties that we have to extract via bitwise operations. So, in terms of interpreting this data, the difficulty obviously ranges from quite easy to relatively hard. So if it's a simple, straightforward string or number, that's pretty straightforward. If it requires bitwise operations and for you to know the values of various different flags, that's a bit more challenging. Then you've got binary attributes, which require very specific parsing. That's challenging again. And then you need to find a way to establish relationships between a lot of these objects. And sometimes those relationships are based on parsing one of these other difficult attributes. So this is really the point where if we're looking for attack-specific use cases, that we need to use tools. So for the rest of this, I'm going to be explaining how the process works by the medium of a tool. The tool is BloodHound, which some of you may have heard of. So this is a tool created by SpectreOps a few years ago. The purpose is basically to identify attack paths and hidden relationships within Active Directory domains. It does do Azure now as well. I won't be covering that in this talk. So the tool works by basically collecting a bunch of network information. It puts it in a database, and then it uses graph theory to identify relationships between objects, and then it presents it in a helpful way so you can actually actively use the information to find attack opportunities. This here is a screenshot of the BloodHound Community Edition. So we've got a few different components in this user interface. In the centre here, we have a yellow object that is surrounded by a number of different green objects. There are links between these objects to indicate that a relationship exists between the objects. Each of these links is labelled to indicate the nature of the relationship. So in this case, the central object is a group, the surrounding objects are members of that group, and all the lines and descriptions indicate this. Over on the right here, we basically have a number of different properties associated with the central object that we can look at if we want to. Top left here, we've got a search field, which allows us to search for the object that we want to appear here by name. Then we have a very interesting option, path finding. What this allows us to do is try and determine if there are relationships between some object we have control over, say if we've compromised a user account, and some other object that we might want control over, such as the domain admin groups. Pathfinding will tell us if there are relationships between that object and other objects in between, potentially, that indicate an attack path exists to go from one object to another, to go from simple access to maybe domain admin. To actually populate this information, BloodHound has a set of tools known as collectors. And what these basically do is they query the Active Directory environment in various different ways, take the data, specially format it, parse it, put it in JSON data files, and then those files can then be uploaded directly into the BloodHound user interface to basically populate the data that we're going to be looking at. So what is the relevance of all this to LDAP? So when we look at the way the collectors actually work, we find that the majority of the information that they get, at least specifically for Active Directory, is available to low privileged users, comes from LDAP, and can be collected rapidly from a single source, one domain controller. There are other categories of information as well, other collection approaches that the tools use. They often require more time, more connections to more systems, higher privileges, and they can be more likely to actually fail. So they can be, you can increase the opportunity that you might get caught without actually getting value back. BloodHound also has a concept of collection categories which largely align with these collection approaches, and we can actually look at these to determine what components of the collection are done using LDAP. So what we have here is a screenshot from the source code of SharpHound, which is basically the C#, what I call the reference collector for BloodHound, Active Directory specifically. So in this is a listing of all the different collection approaches that are supported by the tool. So we've got a number of different individual approaches here which have numbers associated with them, and then at the bottom we have groups of these different collection approaches. And the groups are basically kind of put together based on either the target that they're going after or the collection approach or technique that they're actually using. I've got one category highlighted that we're going to have a look at in more detail. But first, I'm also going to mention that there is some stuff that SharpHound does, that it collects, that is not associated with a collection category. This is basically stuff that it just needs for every operation. It's the kind of baseline for what it uses, for what it considers to be the standard. And this is collecting information from LDAP again on users, computers, and the domain and forest objects. So the associated LDAP names of those different objects are included on the slide. Now let's jump over and have a look at this category of collection approaches known as DC only. So as you might guess, the category is named this because it is collection that can be done from a single domain controller. And when we look in detail at how each of these work, we find that the majority of them only use LDAP. There is one exception, which I've crossed out right here, GPO local group. This requires that you connect to the file system of the domain controller, pull back its group policy objects, and parse them for local group membership information. Let's have a look at these in detail and see how they relate to LDAP. So these four categories of collection basically just involve getting particular types of LDAP objects. So we've got containers, which is getting container and organisational unit objects from LDAP. We have groups, which is getting groups and their members. We have trusts, which is basically information about trust relationships with other domains. That is the trusted domain objects. And we have cert services, which is about the configuration of certificate services. And those are these three objects. Next, we have the object props category. So essentially, when SharpHound or other BloodHound collectors actually pull back information on network objects, they only get a limited set of information. If we have object props turned on, more information is collected. And in the case of users and computers, for example, this is stuff like the last logon time and the password last set time. Now, even with this turned on, it doesn't mean everything is collected. There is still a bunch of default values that are not particularly useful, that it excludes. There is an option to actually pull back all attributes. In most cases, this will not be useful, but there can be cases where there are custom attributes in an Active Directory domain which can have useful information, and you're basically only going to know about it if you try and pull back all the attribute values or if you look in the schema. So far so good. All of those are pretty simple. However, there's one category that I've left for last, and that's the ACL category. So the ACL category is relating to object security relationships, and it basically describes the ability to access or control the object that it's assigned to. So basically, when we're looking at a lot of those different relationships in the BloodHound interface, a lot of these are actually filled in by this category. So this basically has the information about what can do what to what can, and from that we get information about abuse potential. So the required info for this comes from one attribute on each securable object. It is known as the NT security descriptor. It's a binary field that has multiple components in it, and it requires specific parsing to make sense of. It contains 4 different main components. It's got an owner user and an owner group. Both of these are referenced by SID. So SID is a security ID which is assigned to all security principals within an Active Directory domain, and it's unique within the domain. If you want to turn the SID into a friendly name, we've got to do a lookup to identify it. Then we have the discretionary access control list, shortened to DACL. And this defines permissions, individual permission sets for principals accessing the object. Then we have the system access control list, shortened to SACL. And this defines the auditing configuration in place on each Active Directory object. The last one, the SACL, is not used when we actually do this ACL interpretation for finding abusable permissions. This here is what the structure of that particular object looks like. There's more problems though. So, as I mentioned, this particular attribute has multiple different components, 3 of which we need, 1 of which we don't. But not all of the components are actually readable by all users. So the bits we need, the owner user, the owner group, and the DACL, are actually readable by all authenticated users by default. The SACL component, however, needs a privilege permission to actually get or set. It's known as the Access System Security Permission. Most users don't have it. And the presence of that one attribute, or that one component of this attribute, can prevent us from getting those bits we're actually interested in. So how do we work around this? Well, LDAP actually provides us a query control that we can use. The LDAP server SD flags OID. And what this allows us to do is provide a mask value for the components of this security descriptor we actually want to return. So if we set this on every query that we perform where we want to get back this attribute, and we use the value 7, this will mask in the owner, user and group, and the DACL, and it will mask out the SACL. So what we will get back essentially is this structure, but the SACL component will be all zeros. Then there's more parsing to do. So the DACL list has a list of access control entries, and basically each one of these links a security principal with a set of permissions that they have to that particular object. And it makes up the majority of the information of these abusable ACL permissions. ACEs have 2 main high-level types. They can be allow or deny. BloodHound, when it's considering abusable permissions, is only looking at allows, so the denies are completely ignored. In addition, the BloodHound collectors also simplify the interpretation of a lot of these ACEs down to abusable permission sets only. So in some cases, certain ACEs will be completely ignored if they don't contain an abusable permission. In other cases, they will be simplified down to the abusable component. Now, when we're parsing this, there are 2 different types of these types of ACEs, of the allow ACEs, that we need to know about to parse. They are the access allowed ACE and the access allowed object ACE. Let's have a look at what they look like. So both of those 2 different types of allow ACEs use a standard header, which looks like that. Then the access allowed ACE, the simpler type in particular, looks like this. So it has a mask which stores an integer value, and then it has a SID, which is a security ID, as previously mentioned. And again, this needs to be resolved to a friendly name via a lookup process. Now on this next slide, we'll see what we see when we actually parse one of these ACEs. So we have our SID here, then we've done a lookup to resolve this to a friendly name, In this case, it happens to be a group object. Then, down here, we have our mask integer value, and the mask is actually used to determine these privileges. The way this is done, you need to know the full list of privileges, you need to know numbers associated with them, then you need to perform bitwise operations against the mask to determine which of the privileges are actually present. So, that's what this particular parsed ACE looks like. Now let's have a look at how BloodHound, the BloodHound collector, actually simplifies it. So it comes down to this, basically. So it's a lot simpler. We have the SID still. Instead of resolving the SID to a friendly name, in this type we've resolved it to a type of object. So in this case it was a group. Then this right name here basically describes the abusable permission component. So if we go back to the previous full version of this ACE, you will see we've got a number of different permissions. Generic all happens to be there. And in this case, this is basically the highest level privilege in the list. It's basically like the full control of Active Directory. So it's simplified just down to one permission set. Now let's have a look at the other type of this type of ACE. So it's quite similar in a lot of ways to the simpler version, except we have a few additional fields. We've got flags, we've got an object type, which is a GUID value. Then we have an inherited object type, another GUID value. Now, as I mentioned, both of these are GUIDs. They need to be resolved back to a friendly value via a lookup of that GUID in the LDAP schema. And then you need to look at the flags value to determine whether you actually pay attention to either of these as part of the parsing of the ACE. So here is an example of a parsed one of these ACEs. So the additional fields of interest are the ACE data flags. In this case, it has ACE object type present. And that means we need to pay attention to the control object type, and we've resolved that to a friendly value via a GUID lookup. Now let's have a look at the BloodHound representation of same. So in this case, the other components are pretty similar to the previous one we looked at, but the right name in this case has been deduced from two things at once, and I think in this case even it's from two entirely different access allowed object ACE objects. So we've basically combined two into one. So why did I subject you to all that information exactly? It's really just to drive home a point. The ACL stuff is really, really useful when we're looking for attack opportunities, but it's a real pain in the arse to actually get at unless you have some sort of tool to do it for you. Or to put it another simpler way, just use a tool. There's a problem though. As I've shown, BloodHound does a lot of work for us, but there's cases in which it doesn't operate as you would want it to. So let's have a look at some of the limitations of the tool to see how this might happen. So one of the biggest issues that you might have in using BloodHound is that it's basically designed with a particular premise in mind. It's designed to run on a compromised Windows machine, usually a workstation, that is part of an Active Directory domain that you want to actually enumerate. So as such, it has access to a lot of information about the domain it's a member of. It can generally talk to all the right things it needs to talk to, and it has access to an active authentication session that it can abuse to actually make the connection that it needs to make and query the information that it needs to query. If you try and run the tool in other circumstances, you can have difficulty. So if you need to specify credentials in a really particular format, that can be difficult. If you're trying to run from a location where you don't have free and easy access to the domain controller, that can be difficult. If you don't know where the domain controller is, it can also be difficult. So that's one big problem. The second problem is it's very heavily targeted by lots of different security tools. It's pretty well known. And there's a decent chance you're going to get detected or blocked if you just run it blindly without thought. So, in the cases where that tool doesn't work, there are two different alternatives I'm actually aware of. The first is the Python version of BloodHound. So, as you might guess, it's basically a Python implementation of a BloodHound collector, and it uses a lot of the same collection approaches that are supported by SharpHound, so it's not just LDAP. It does work on machines other than Windows machines, and it gives you a lot of flexibility in terms of what authentication approaches that you want to use and how you want to specify those credentials, which is nice. It is still reliant on good network access and DNS for it to actually work, and can fail if you don't have this. And it's also, in some ways, an older implementation, so the current fork of the tool doesn't support the new BloodHound user interface. There is an alternate fork that does. However, I don't think either one of them actually supports some new features, such as collection of information about some of the certificate services attacks. Then, the other option, which I'm slightly biased towards, is my thing. It's named AD LDAP Dumper, so I have a great imagination when it comes to naming tools. It's LDAP only, and it's very, very configurable, but it's a lot harder to actually make use of. So, a bit more detail about my thing. I wrote it in Python. It runs on multiple platforms again. It supports a number of different authentication options, so you can do anonymous binds, you can do user and password, it does NT pass the hash, you can use Kerberos tickets. So if you're familiar with how some of the in-packet examples uses Kerberos, this does the same approach basically. It pulls from a local cache file. One of the best features I think about this tool is the fact that it's basically designed to work with a minimum required access. So if you can talk to the right port, so TCP 389 or 636, and you have some form of valid credentials, it's probably going to work, and it's going to pull back all that good information you want. It also tells you when you're connecting and when you're enumerating whether the server you're talking to is a global catalog server or not. And it enables you to do some of that anonymous bind collection information, the collection approaches I was talking about earlier. There's also a number of different options I've added to it to allow you to avoid detection of various different kind of server-side detection methods. And about 6 months ago, I added an option to actually produce BloodHound output files. So normal people other than me can actually use it. So the tool previously used to dump all the information into JSON, and no one else I showed it to was able to make sense of it. So I decided to add BloodHound output so that normal mortals could use the tool as well. Why did I write this thing? Basically because I needed something that worked under those restricted circumstances. And there's some options about avoiding detection that were very useful to me at one point, not so much anymore. Basically, there's options in there to allow you to avoid tools like Defender for Identity, and probably about a year ago they actually removed a certain requirement for LDAP query logging, and once they did that, my tool was no longer detected anyway, so some of the detection approaches that I've trying to avoid, I don't really need to anymore. And also, I think it's good for other people to use this now that I've actually added BloodHound support. So that's it.
Thank you, Stephen. We have plenty of time for questions.
G'day. The only question I had was actually for the thing that you mentioned near the end, where you said that they removed a lot of the protections that you literally built your program to evade. Yep. Did you find out a reason as to why they would do something like that? Because it just sounds like...
They didn't check in with me, but I think the reason was that basically the collection requirement, so it was basically the requirement to collect LDAP query logs. This actually can pose a pretty significant performance and storage implications on domain controllers, so I think it's probably because of that reason why they actually did it.
Yeah, so more like availability over security concept.
To some extent, maybe they didn't think, that it really needed to focus on LDAP detection or something like that, I don't know.
Yeah, cheers. Thank you.
No worries.
Any other questions? Stephen, here's a gift from BSides Canberra. Thank you for helping.